Alright, so in today's episode of Python Papi, we're back inside our TensorFlow course and we're still doing our corrective measures module. Let's have a look at what we went over today. Now, yesterday, if you recall, we were in the process of making our models more complex using our ReLU activation function. So let's pick up where we left off. Now we have everything we need to make our model perform better and stop underfitting. We will add a dense layer to our model .correct.sequential.function, and let's say we have 32 neurons. So our output would be 32. Then we add another dense layer with 32, and we will add a final dense layer of 32 next. And lastly, we want one output. We will have a final dense layer, which will represent our output layer, which has only one output. Next, we will specify the activation. So we'll have the activation equals ReLU. We will do the same for each of our dense layers, but not for the output layer. That is because we don't want to interfere with how our model comes up with outputs. Let's have a look at how that looks right now. So this is, and then we run our model. This is the example of how we would run it here. We have model equals dot, or model equal tf dot correct dot sequential, and then you can see our parameters entered there. We have our input layer, we have our normalizer, we have our three dense layers, and then we have our last dense layer, which is actually our output layer. Now note, this is also another way we can run this algorithm right here. The model equals, it's the same exact thing right here, just written in a different format. So this right here is exactly the same as this, and I'm going to actually start compiling now. I'm sorry that I didn't start compiling earlier, but yeah, as you can see, these two will be the same exact outputs when we do actually run them. And yeah, and I did have a little issue this morning with running this program. I don't know why, because our input layer was not being recognized or wasn't being defined inside of our function. So I had to figure out what was going on, find a bug with that. Come to find out that I didn't have it imported in this section here. I added it because I checked my other modules to see that the input layer was added. I didn't know that it wasn't added in this section, so I had to go back and add it. Took a good little while to figure out what was going on and why it wasn't being defined, but we finally got it going, and we got things back on track. But yeah, that's what we did this morning. We actually went over the process of making our model more complex so we can actually have less loss value differences between our models, and we can come back with more accurate numbers. But like I said, the reason I have these two back to back is because they're exactly the same, it's they're written in different formats. And I can show you what that looks like over here in our data preparation file where we actually launched it at, and you can see I have them right one after another. So you can see we have this format here, and it's the same exact as the format beneath it here. Hold on, I don't know why I'm all over the place with the mouse today. Here it is here. So it's the same exact thing. And you'll see that in a second when this is done compiling. Let me actually make this bigger because we're done looking at the code there. We can actually make that bigger so we can get more of the screen focus into the video. So our plots should be popping up soon. And you know the deal with the plots. We have to go through everything because one thing leads to another. So everything has to stay the same. If you remove one thing, it might throw everything out of whack. So I just left everything the way it was so we can run it for this video in training purposes. And again, this is our corrective measures module. So what this is going to do is it's helping us correct that underfitting issue that we were having before. You saw the big difference between those numbers when we ran them last time. Our predicted price versus our actual price were way off. So this is going to help us bring those numbers closer together. Once we dive deeper into it, I'm pretty sure there's more to it than actually just running the sequential dot, dense layers that we did add to it, but we'll see once we get there. Again, I'm just waiting for this to compile so I can show you that the two functions or the two algorithms are exactly the same. They're just written in different formats. And then we can actually go through what those actually bring back once we run them. So we should be getting our second set of plots coming up soon. Here we are here. It's plot 1, plot 2. And now we can move on. Okay, so here you see our latest graphs here. Let me go ahead and go through these. Yes. There's a crazy glare out here. It's always hard to see with this glare. What happened? Why did I close my terminal? Why did I close? What happened? There it is. Sorry about that. Okay, so you can see here we have our sequential one. So they're labeled sequential 1 and sequential 2. Don't get that confused. They're not different. They're just labeled sequential 1 and sequential 2 to make sure that you know that they are different sequential models, but they are exactly the same the way we input them. So you can see here we have our dense layers, 1, 2, and 3. Our inputs that we made, 32, 32, 32. These are the parameters we can get back from each of those layers, 288, 1056, 1056, and our output layer, which has one output, and that has 33 parameters. And that gives us a total of 2,450 parameters, and that gives us 2,433 trainable parameters with 17 untrainable. And that 17 traces back to our normalizer. I'm not going to go back into that one now, but it's locked in because we didn't change our normalizer, so it's still 17. So if you add 17 to the 2,433, we would get the whole total number of parameters. So that's why that number is there. But yeah, and that's the exact same model as the one below, like I said. So you can see sequential model 2 is exactly the same. Let me go to it. So we have our dense layer 1, 2, and 3, 32 outputs, parameter 288, 1056, 1056, and then 33. Yep, so that's what we did this morning. We just went over the process of making our models more complex. And what we're going to do tomorrow is we're going to add more neurons, or we're going to make this number larger. We're going to try 128. I was going to do it this morning, but like I said, I was having an issue with the import layer and why wasn't it being defined. But yeah, we will definitely say that for tomorrow, and I will keep you guys posted every step of the way. But for now, this is the Python Papi, and you guys stay Gucci.